So the second question is 2 N2OH4 grams plus N2O4. I don't know what these are, so I'm not gonna say them. And then they react to make 3N2 and H2O. I know what H2O is. H2O is water. So, and there are some givens here. We have 8 grams of N2H4 is mixed with 92 grams of N2O4. So the question is, what is the maximum mass of H2O that can be produced? This is the same question as question B that we had in the last question, but the last question had question A and question B. So this is both of them combined in one question. So the first step, as the last one, is to convert the 8.0 grams of 2N2H4 from grams into moles. And actually, it's not 2N2; it's just N2H4 because we don't take the moles of it. It's just N2H4. I'm sorry for this. So for converting from grams into moles, we're gonna use our lovely, lovely, lovely triangle. So that's gonna be from grams to moles. So for doing this, we're gonna um, for getting the moles, and we're gonna divide the grams by the moles. We have the grams over here, so that's gonna be 8.0 grams over the molar mass of this, which is 32, and this will be 0.25. Yes, sorry for this. And that's gonna be 0.25 moles of N2H4. So the second step is to convert from moles of the reactant to moles of the H2O, as I said. So that's gonna be 0.25 times, as we did in the last question, the the mole ratio. So here in the product it's 4 because of the H2O. So we look at the H2O and the moles of it. It's 4, and to the N2H4 it is 2. So that's 4 to 2. As we said, we always put the product on top. So that's gonna be 4 H2 of H2O. That's for the H2O, and this 2 is for the N2H4. H4, yes. Don't let these confuse you. These is just you need to label them. I mean these. So now we're gonna make 0.25 times 4 over 2, which will be 0.5. So this will be zero point 0.5 H2O in moles. That's going to be zero point 0.5 moles of H2O. It's like, yes. I'm sorry, just I should have written it in a, like this. So this is the first reactant. Let us now do the second reactant. So the other reactant is N2O4 as given in the equation. Yes, N2O4. N2O4, so we have 92 grams of N2O4, so we put this 92 over here. Then for converting from grams into moles, here we have the mass in grams, and for getting the moles, we should make the mass over the molar mass. So the molar mass of N2O4 is 92 as well. So this is in grams, and this is in moles per grams because I shouldn't mean it's moles per grams because it's from the periodic table. This number is from the periodic table because it is the molar mass. So this will be 1, obviously, and it will be 1 mole of N2O4. Then we will see the mole ratio for doing the second step, which is convert from moles of the reactant to moles of H2O. So the mole ratio of the H2O is 4 as it is, and this one is 1 because we have nothing here. So that's 1. So that's gonna be 4 to 1. H2O, that is 1 and 2, O, 4. So this is related with this, and now we're gonna make 1 times 4 over 1, which will be 4. It will be 4 moles of H2O because we just converted it into H2O. That's a big O, by the way. That's like that should be considered as 3 O's or something like this. So now we have the second reactant. It's 4. So by now we have zero point 0.5 moles of H2O, which was from the N2H4, and we have 4 moles of H2O, which was from N2O4, the other compound. So now we should determine the limiting and the excess reagent. So of course 0.5 is the limiting reagent because it will finish before the 4 because it's bigger. So 0.5 is the limiting and 4 is the excess. So now for the last step in this video. Convert the limiting reagent from moles into grams to get the final step, the final answer. So the limiting reagent is zero point 0.5 moles of H2O, and we should have had here our triangle, but we are big enough now to memorize the triangle. So the triangle would have shown that we should multiply the molar mass by the amount of moles to get it in grams. So because we need it in grams, so that's going to be zero point 0.5 times 18, because 18 is the molar mass of H2O. So this will be 9, obviously. It will be 9 grams of H2O. So this is the final answer. 9 is the final answer. So the maximum mass of H2O that can be produced is 9 grams of H2O. And that's it for this video. It has been Mahmoud Sameh with you, and I hope you have understood anything from this video. And that's it. Have fun.